Hello and welcome back to Coder Key. In this video, I'm going to check whether the given number is power of 2 or not. Another problem on bit manipulation. So let's get into it. So the problem statement that we're given with is we are given with a number n, okay, and we want to check whether the given number is whether the given number is power of 2 or not. Okay, so let's say we are given with the number 21. We have to check whether the given number is power of 2 or not. So of course this number is not the power of 2. Let's say we are given with the number 32. Yes, it is the power of 2 to the power 5, right? So what I'm going to do is we're going to discuss 4 methods. Okay, the first one will be very naive. Okay, the second one will be using something that we have studied before, and that I'm going to code, and the third and the fourth method will be something that you're going to code, and the solution will be available on the GitHub. Okay, so the link is in the description. So now let us see the very naive, the first method. So now, first of all, the number is going to be the power of 2 only when the number is even, right? So now, first of all, we're going to check whether the given number is even or not. If the number is not even, if the number is odd, that means it is not in the power of 2. So first, the base case will be checking whether the given number is even or not. Now, if the number is even, then we're going to continuously divide the number by 2 and wait for the result to become 1. Then we can say that, yes, the given number is power of 2. Okay. Same we can do for 21. It is not even, so it is not the power of 2. So let's do it for 32. 32 divided by 2, that means yes, this is the power of 2. Okay, so this is a very naive method that you can solve, continuously dividing it by 2. Okay, and if the number is 1, then yes, it is the power. Now let us talk about using bit manipulation. Okay, bit magic. Okay, the first method. Okay, that we're going to code. Okay, now using bit manipulation, what we can do is we all know how do we represent binary numbers in power of 2, right? So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, okay, and 2 to the power 5, right? So this is how we represent binary numbers. Now if I want to represent 32, the representation of 32 will be this. Okay, so this is 32. If I want to represent 0, right, so this is 0. So now what you can observe in all these power of 2's, that if the set bit is only 1, the count of set bit is only 1, then we can say that the given number is power of 2, right? So what we want to do is we want to count the number of set bits, and if the count bit is 1, then we can say that the number is power of 2, right? And for counting the number of set bits, we have studied in the previous video that you can check it out. We're going to use Kernighan's algorithm, right? Kernighan's algorithm. So what we do in that, what we do is we AND it with the number and the number previous to it, right? And if we get all zeros, then then we can say that the given number is power of 2, right? So that means if it is null, then we can say that the given number is power of 2. If it is not null, then we're going to say that the given number is not the power of 2. So let's code this out. Okay, so let's see what we have. We are given with a number. Okay, and now what we're going to do is if, and we're going to check whether this is not null. Okay, so that is, it is true. If n number and with the number before it, now -1. Okay, if this is equals to 0, okay, then we want to return true. Okay, and else, okay, or return false. Okay, so let's see. So let's see. So let's see 32. Yes. Again, let's see for 21. No, right? So this was very basic method. Now let's see another two methods that I want to tell you. The third method is using bit shift. Okay. Using bit shift. What we're going to do is, let's say we are given a number, we are given a number 1000. Okay. Now what we're going to do is, we're going to right shift these this bits, and we're going to check if the bit is set. Okay. Now if the bit is set, then we're going to see if the number is 1, then that means, okay, if the number is 1, then that means it is in the power of 2. But if it is not 1, then it is not in the power of 2. Let us take an example. So we have this number, okay. We're going to right shift. If it is not set, then again we're going to right shift. It is not set, again we're going to right shift, and we are here. It is 1, okay. And we're going to check if the number is 1, then yes, it is in the power of 2. Now let us check for 1 1 1 0 0 0. Okay. Now we right shift because it is not set. We right shift because it is not set. We right shift. We right shift and we encountered 1. Okay. The first one we encountered. Okay. Now we're going to see what the number is, and the number over here is 2 to the power 3, 2 to the power 2, 2 to the power 1, and 2 to the power 0. That is 4 plus 2 plus 1. That is 4, 5, 6, 7. So number is 7. It is not equals to 1. That means it is not in the power of 2. This whatever this number is, it is not in the power of 2. Okay. So this was the third method. Again, the complexity of this method is big O of log n. Now the fourth method we're going to use is ceil and floor operations. Okay. So now basically before that, what I want to discuss is, let's say we are given a number, if you want to have a log of base 2 with a number to the power n, what we're going to get? We're going to get n, right? So now what we're going to use this thing over here. Okay. So now let's say we are given with few numbers, the same number that we took before, 32 and 21, right? What we're going to do is we're going to calculate the ceil of log of base 2 n and floor of log of base 2 n. So what is ceil of 2.4? Ceil of 2.4 is 3. And what is floor of 2.4? Floor of 2.4 is 2. So now if I calculate ceil of log of base 2 32, I'm going to get the log of base 2 32 is, first of all, it is 5, right? So ceil of 5 is 5. Similarly, this the floor of log of base 2 n, that is 32, will be 5. Now what we can observe is we got both the ceil and floor as same because the number was the power of 2. Now let's do first same for 21 also. Okay, so ceil of log of base 2 21, what we're going to get? 21 is 4 the log of this is 4.39. That means the ceil is going to be 5, right? And now the floor of log of base 2 21 is going to be 4.39's floor is going to be 4, right? So now here we got different ceil and floors value. So if the ceil and floor value are equal, then we can say that it is the number is power of 2. If it is different, then we have to say that the number is not in the power of 2. Now this is going to bring us the complexity of big O of 1, okay, optimized of all. And the code for these two will be available in the GitHub. You can try it out first. Okay. So yeah, this is it for this video. You can check out, you can subscribe, okay, as well as you can check out the GitHub repository where I'll update the solutions. Okay. So yeah, thanks for watching and have a nice day.